top 5.
Yeah. Oh yeah, so we were talking about defining, well, the fact that we have stable. So then we were talking about operations to someone for familial being raised by parent or parents or guardian. Familial proportion having stable parent structure, so actually having consistent home living place. And then that's so should that is that what it was? So
we want to make sure we have people from all
schools.
Then join like couple of faces are yeah, we can do it.
Yeah, yes, it is.
Okay, so probabilities ratified by
I personally like to look at New York and Granville in comparison to one another.
How would we choose like which students integrate to study? Just like all those who dropped out.
Okay, so
I think we would look at, I mean, well, we have even more clearly defined in terms of 7th grade. Maybe pick, I mean, it really depends because some schools have like one or two or three 7th grade classes. So if a school has one 7th grade, one 8th grade class, you know, we'll get both of those. If they have 2 or 3, let's pick this one classroom at random to observe, and then, you know, well, we're already like grade specific, but then classrooms are like,
Would you study the entire class?
also we can send out reminders.
yes. I think what we're looking for, I think it would be really accessible. Degrees and trust us.
Not yet. This is my first. I just had a meeting with Coach Barling, the tennis coach. Yeah, and then I have a tour and an information session a little bit later. Yeah.
Wait, actually, I think those are.
Students watch us over here, we take advantage of each other's expertise and so forth. So we try to make it as interesting.
Yeah, I like that conversation-based class. It's interesting. Yeah.
And we'll do a little bit of hands-on conversation. Yeah. So try to very different from the experience that you might have at a huge school where there would be one professor showing students in the class.
No,
Yeah,
we're just trying to get a snapshot.
I think the first
And that's one of the major
possibly
course
to
that is you
if
don't have classes
parents'
about 20 or so.
information isn't like up to
That's
date.
nice.
You know what I mean?
More individual attention.
A survey just to get into the students.
Did you have a study flight from?
I think it's
In theory, but we got diverted because of, yeah. That was a long day.
This is snapshot.
in-person interviews in which
We're not following the same as the students.
for a personal interview, is it possible to do the interview and also have a survey?
Sure, if you like to do.
So I think like create some kind of survey, have these students fill it out, and then also do an interview based upon their.
For the survey could tell us like how much their parents made or whatever, like their on paper or actually
There are random samples, but like ideally, when I do this, I want to get there for something, but also want to write them on like see how they would separate.
So maybe August, the August to the maybe the December.
What does that mean, convergent validity? Because does that mean that?
Oh, right, yeah.
Is that the one that like things correlate?
I think so.
Well, we can.
the last one is
So is that independent measurements of a given constant are correlated?
also says for each of these draw a graph of the data. So establish
Yeah, those two should
I think that like as long as we have one survey that we follow like for
How would
everybody.
you establish like reliability of this?
So, like,
Okay, you don't have to
Just say that we could do a meta-analysis.
So
Of others' study.
making sure that we're going after we're going after stability here, and we're going after financial stability here.
I don't know exactly how.
Because we're not supposed to.
one's on this side, one's on that
More
side.
like that.
That's what we
So I don't know,
I think I definitely think that if we're looking for one thing in their survey and one thing in their interview, that can help us. Separately.
We're a little bit confused as to how to do discriminant validity.
Okay, that's the third group that came up with that. Who's having trouble with discriminant validity? Has anybody tried it? Has anybody gotten an idea about that? Do you have an idea about
We
this?
think.
You think so? Okay. Why don't we do it this way? Why don't we, it's just about our stopping point anyway, why don't we see if we can get a group to start us out on number 5, on which of the 4 survey methods. So here, for Aaron's method, we always do this by random number generation. Aaron's
Stop.
Stats class right. Aaron's taking the stats class right now. Brittany's our most enthusiastic stopper.
I am.
Okay, Brittany, you stop us.
Stop.
Okay, all right. And Giselle is up. So Giselle, I wonder if you can tell us how you can address number 5, which of the 4 survey methods, and maybe you can give us an overview of what your research question was to remind us.
Our research question is, are Denison females in Greek life more social than OSU female students in Greek life?
Okay, so we have, it's all females, it's all sororities, and it's OSU versus Denison and sociability.
Yeah.
Okay, got it, thank you.
Okay, and we would plan to use internet interviews because of the number of participants.
Okay. Okay, that's really good. Okay, so it'll be some kind of internet survey? Are you doing this by Skype, or they're filling out like one of these, one of the things we have at the moment here?
One of the things that we have.
Okay, so it's one of these, and they might be on something like SurveyMonkey is an online bit. There's something else called Mechanical Turk. It's done through Amazon, and you can do large internet-based surveys through these packages. So they might do one of these, okay, and we're asking sociability questions. I wonder if I can stay with that. So which of the 3 designs did you use? So So,
Successive independent.
that is a mouthful. It's successive independent samples. Okay. All right. So, can you remind us what that is?
That is a longitudinal, no wait.
It's similar to longitudinal ensembles. How is it similar to longitudinal? Can anybody help us out with that? How is the successive independent samples design similar to a longitudinal design? Or how is it different? Can we help to remind us about that? Yeah, thanks, Pam.
I think it was taken over a long period of time.
Both taken over second interval time, not just one time only. Okay. What else do we know about it? Between subjects or within subjects? Successive independent samples? Any between subjects as independent samples would be this. Okay. All right, so we're going to be sampling these folks over time to see if there may be cultural changes across time and then possibly between two schools. Okay. Now, did you have some idea about reliability, convergent validity, and schema validity, or did you not have so much background? Some people got stuck there.
We're starting on it. Reliability is through the test, retest method.
Okay, thanks, Megan. If we can pick up on that. We're going to do the test retest method to get the ball rolling. If you, either of the two of you can help me out here. So this is all about reliability. And we're going to use the test retest method in your case, is that right? All right. So help me out. How might I get my axes labeled here?
Well, I guess you could do like at the bottom, like I guess like email retype for like Dennis, like label it like the different, I don't know what stories they have there.
Okay.
But
Okay.
I guess like the different like Denison versus OSU, and the other one would be like we're measuring their like sociability.
Okay, so sociability would be here. We have different indicators. We might have a bunch of sororities that are Denison sororities, another bunch that would be OSU sororities. We might just have Denison and OSU and put them all, the different sororities that we have on campus might all go into one group we call the Denison sororities. And it might be another group that we have over here. Okay? If we're looking at reliability, though, it is test and retest. Can anybody give us another way to get started on our axes? We always want to make sure we're very clear about what we're plotting. So we're doing reliability. So
We were gonna have like one test in the fall, one test in the spring, and then like have, I guess, for this a bar graph, I think. And then you can have like a bar for the fall, right next to the bar for the spring, for the Denison, and then like compare it to.
Okay. Very good. So let's just say that we've got hypothetically 100 women from Denison who are in sororities and 100 women from OSU who are in sororities. Now let's think about that for a moment. What kind of sampling would that be? We have 100 from each of the two schools. Anybody want to begin to try to describe what kind of sample we would have in that case? Talk about different varieties of sampling. Thanks, Mira.
So it would be the probability one because it's just the two stories.
Well, if we're defining, that's a good point. Actually, only looking at the sororities, but if that's our population, then it wouldn't necessarily be non-probability. But that's a good way of thinking about it. Yeah. So Megan, then we put in.
We're gonna use both, like during the state comp here. We're gonna use two surveys during the first like time they take it. So like one where they're all like in the same, the girls in the same sorority are in the same room with each other taking the same test, and then another one where it's just random, you're not with anyone that you know.
Okay.
Just like the same thing.
Okay. So that's there are different kinds of ways of administering the test. That's certainly true. And you might get some social facilitation if you're with your friends. Okay, so that might affect the results. Brittany, did you have an idea about what kind of sampling we were doing for that 100 from each of the schools?
Not so much more, but that second one, it sounded like there was more random sampling in the second one. But
There's a type of random sampling. So let's think about this. Which school has a bigger population overall? OSU. OSU. It's almost like we're talking about, I don't know, maybe California versus Rhode Island or something.
Yeah.
Does that ring a bell? Okay.
Yeah.
So we have different numbers from the two schools or the same number from the two schools? If we have 100 from each, we've got the same. So it's more like the Senate in our representation, right? So we have actually equal sample sizes from the two populations, right? And then we're going to compare them one to the next. Okay. And what we might say is that we're getting some kind of sociability score for each of these, and we might have listed them as all OSU over here, all Denison over here. What we could do is just give an individual, if he gets a very high sociability score at time 1, And then also a very high sociability score at time 2, and that person would be up here. Okay? Somebody else might get a low sociability score in both of those. Somebody else might get an intermediate score. The actual bit might look like this. Okay? So we had 100 from each school, so I'm going to have 200 dots. Okay? I won't actually stand here and do 200, but you'll get the point. Okay? Can we all draw the best fitting line for that? In here, can we do that by gesticulation? Best fitting line is going to be something like this. Aaron, have you done an R value? Aaron is taking the stats course. Have you done the R statistic, the Pearson R? Or not?
No,
Okay, that's
sorry.
okay. No, that's quite right. That's how we might see if that was familiar to you. Can we all yell out a plausible R value for this? 0.7-ish, okay. If we have an R value of 0.7, what would that tell us about reliability? Generally? Relatively strong reliability. What would this look like if we in fact had no reliability? What would the best fitting line have to look like? There it is, flat across. People are going on a flat line. We have a circular cloud of dots, and it would be flat. Okay? So we can give sociability questions. Maybe there are lots of them. And we get a sociability score for you at time 1, and then did you say fall and spring? Is that what we use that with one? Okay? So this would be maybe the fall measurement. This is the spring measurement. And to the extent that we got R values greater than 0, we could argue that we had test-retest reliability. Who's okay with that? Anybody unclear about that? That's actually a very nice start. All right. All right. And then we didn't get to convergent validity or
We're still discussing that.
Okay. All right. Anybody? Let's see if we can open it up to the class. Let's see if we spend a moment on convergent validity and instrument validity using what they've got. They've got 100 women from OSU. They've got 100 women from Denison. They're looking at sociability, how social these folks are. Okay? And they're using their own brand newly created survey on sociability. Okay? How about we begin to think about convergent validity? Take this off. Give you a clue that we might have a scatter plot also. This time it's convergent validity. Any notion about that? Yeah, thanks.
I think you use like the sociability scale as like one of them. I think the kind of.
Okay.
And then I think we do like a similar trait that's correlated with it. Like someone who is sociable is also like active. Like
Okay.
satisfaction.
That's actually going to be a really nice one, I think, for discriminative value. So it's similar, but not exactly the same. Okay. So they're measuring sociability on our scale. Right? They really want to measure their own scale. We'll call it our scale. And you've got sociability, which I'll put as social, because we have their own index of being social. Okay. And then what do we need to have over on this axis if we want to establish a convergent validity? Here's one measure of sociability. In case of convergent validity, we need to have some other kind of measure of sociability. Maybe there's already an existing scale of sociability that we'll call the ACME scale. How about that? Okay. Is that what the Roadrunner has? Yeah, he's always got the ACME food or something like that. Okay. So we'll call this the ACME scale. I just made that up. Here's the ACME scale of sociability, ACME Soc. Let's assume that's a very well respected measure of sociability, and these young women are now putting together their own scale. And if they want to say that their scale has validity, they can say, well, our results converge with those of the ACME scale. So they might have the same people taking the ACME scale for sociability and their own scale. And if we do get a pattern that looks kind of like this, and if we're back to something like a 0.7, what would that imply?
Good convergent.
That we have converged, that our measure of sociability, and we're just cooking up here in Site 200, converges with the ACME scale of sociability. But we might not actually find that. We might find instead is that we get that much dreaded circular cloud of dots. And the best fitting line is going to be flat as a pancake. Our value here will equal really loud. 0, okay? And this would mean that actually we thought we had validity, but when we do an empirical test, we can confirm that we have at least convergent validity with this well-respected instrument of social validity. Who's following that? Does that work for us? Okay. Now, Meg was right on top of the possibility here for discriminative validity. It's the same kind of validity, but we'll take this guy out. We're still looking at our scale. we're hoping that it can discriminate between the very concept that we want, which is sociability, and some other construct which might be similar, but not exactly the same. We're hoping that we have that level of precision conceptually. We can distinguish two similar but distinct concepts from one from the next. So this will be discriminative. All right. Next, you want to help us out with, you were kind of there a little while ago.
Well, it would be our scale. Yeah.
So our scale's gonna be here,
social,
right?
and then we would try and well, we would predict a correlation between like maybe our scale, like sociability, versus like life satisfaction.
Okay, all right, maybe that's the case. If we believe that life satisfaction is similar to being social, then that may, okay, let's say that we believe that to be the case. This is life satisfaction. We want to see if our scale can actually discriminate between that. And what kind of pattern will we hope to see over here? Sure.
Positive.
Positive correlation. We might expect, if we want discriminative validity, for this to be either 0 or nearly so that we're actually measuring something distinct from life satisfaction. Right? We're trying to discriminate our construct of sociability with some other one that's similar but not quite the same, and that is life satisfaction. Okay? So it would be really great if we had a 0 correlation, or maybe something that's perhaps slightly positive, not really strong. Who's following that kind of reason? Now, what we might say is we might try to find some construct that's a little bit more similar to sociability than life satisfaction. How about this? How about something like extroversion? Who remembers extroversion from Intro to Psych? Okay? Extroversion might co-vary with being social, but it's not quite the same thing, perhaps. So maybe we would change this to extroversion. And we'd ask, to what extent are we actually measuring extroversion versus sociability if we believe those are distinct ideas? Go ahead.
So do you have to do this, like if you're doing like if you're doing this in real life, do you have to do it with a lot of different variables? Like do you have to do a lot of these?
Yeah, I wonder
Because
if
there's a lot of things that could go with being sociable, or like,
yeah, sure.
so do you have to do it over and over and over again with
Yeah.
different variables?
I wonder if I can answer your question this way. It is our task as scientists to provide persuasive evidence for the methods that we have. So to pick up on your question, if we did this versus extroversion, that would be a nice demonstration. If we did this versus some other variable as well, that would be even further evidence. So the more evidence that you can put forth, then the more persuasive it will be when you try to get this to be published. Okay? You can say that we really are discriminating sociability from this range of similar but distinct ideas, or maybe just one such idea. Okay? So it's how much evidence do you want to put forth in favor of it? Please go ahead.
I'm still confused about discriminability. So are we like trying to find things that aren't, that are kind of the same, but then there's our values which are not actually the same?
Yes, yes, that's right. So conceptually, you might say, let me put extroversion out here. Hopefully, Rachel, it's intuitive to you that maybe people who are generally in everyday life described as being very sociable might be perhaps more outgoing or more extroverted. Now, that might not be exactly the same construct. Extroversion is similar to, but not exactly the same as being social. So we'll put extro over here for extrovert. And if it turned out that we actually had a perfect correlation, one hypothetical, then our scale hasn't really discriminated from the construct of extroverted. If you're extroverted, then you're social. If you're not extroverted, then you're not social, right? If we had a score there of R equals 1, that would suggest that these two are really the same thing. And we're not, our instrument isn't discriminating between the two. Okay? But if we get an R value more like this, then clearly whatever is going on in extroversion is unrelated to what's going on in social.
So why do you want it to be unrelated?
Yeah, why do you want it to be unrelated? The idea here is the notion of precision. Right? That when we're talking about sociability, we mean sociability, and we don't mean things that are kind of sort of like sociability. We mean sociability and not a mere synonym. Does that help?
Yes.
Yeah, so that's a really good question. Right? And we can take advantage of the R value to establish different flavors of validity. We really are converging with other measures of the same construct, and we're diverging from other measures of similar but distinct constructs. That's a great question. Other questions or comments? Okay, that was a good exercise. We never really got all the way back to Brittany and Kip. They had a one example. If you want to share one with us, that's cool. Otherwise, we'll move on. Did you have one that you wanted to do and discriminate on convergent validity?
I think you probably better explain it up there.
Okay. All right. Every once in a while, we get a real good example. I think the sociability will pretty well there. Okay. Why don't we go on and do our next item? What we'll do is we'll open up to today's PowerPoint. Today's 10-7. And we were talking about drawing inferences about populations based on the samples. And we have lots of information. Okay, you move back to your seat and move back. Okay. So here's something that we did in the video. And by the way, for whatever reason, this video was very well watched. I have to say though that several of the watchers came from Alaska. So we put these things up on YouTube. I don't know who actually is watching, but they do give you a map. And normally what happens with my stuff is I just get the lower 48. Somehow Alaska came on in spades, and a lot of Alaskans were watching. And I only posted like 48 hours ago. And so that's okay. It's special just on top of Alaska. Okay, so here we are. We're talking about these. Let's all point to generally which one has the smallest standard deviation. Point to generally. Okay, lower right, all right, and then which one has the fattest standard deviations, then this one, or the widest standard deviations, then that one. And probably the relationship between these and these. So I wonder if somebody can help us out in trying to understand how these distributions might connect to graphs like this, which we see all the time in different kinds of science reports. We're going to get this kind of a layout. Can somebody help us relate this side to this side? Notions there. Okay, thanks, Rachel. Then we'll go to Kim.
Well, like, wouldn't the more narrow graph go like the smaller
That's perfect. She didn't say it. She's doing this. Okay, we can write it on the video.
Yeah. It'd be like less of
Yeah, squishing your heads.
less like +1 or -1 like the standard deviation, so it's closer to the mean.
Perfect. Yeah, so if we look at this guy, for example, there's not a lot of variability around that. If we look at this guy, there's a lot of variability around that. So then Rachel is directly going over here, and she's directly going like this. Okay? It's a shame we can't do that on a test, right? If you do the test, that would actually convey that you do know what you want. If you have a small standard deviation, you get a very narrow margin of variability around that mean, or we can have a very much elongated error bar to correspond to the fatter distributions. Who's seeing that relationship? Is that working for us? Is anybody confused by this? So if you are, this usually does confuse some students. So, yeah, okay.
So the longer they represent the line for examination,
Yeah, so that's a really big standard deviation.
which means there's a lot of room for error.
That's a really small standard deviation. Okay. So this big fat one is this guy. Okay. And that thinner standard deviation is this guy. Does that work for us? And that was a perfect justification. And I think Kim has anything you want to add to that, Kim? Or?
That was pretty much what I had to say.
Okay. All right. Okay, so that's that relationship. Okay. I wonder if somebody, let's do this. This is kind of fun. So here's a list of 4 numbers that you might have seen on the video. And these all have something in common. All 4 lists, A, B, C, and D, all have a mean of exactly 5. How might they differ, though? They all have the same mean. How are they different from each other? Okay, thanks.
They have different standard deviations.
Okay, which one has let's all yell it out, which one has the greatest standard deviation, most likely?
C.
Probably B, we computed standard deviations manually. Have you manually computed standard deviations, Erin, in your stats class? You haven't done that yet? Okay. All right. So we compute the standard deviation for this, and hopefully you can see that A would have a 0 standard deviation. Nothing is deviating from the mean of 5. Okay. All right, let's get into some of this stuff. There's some really fact distributions out here. This is one. Okay. Thinking about majoring in geoscience. Did you know that the average geoscience major who graduated from the University of North Carolina in 1984 earned $600,000 annually? Can somebody tell us what's wrong with this picture? Jenna can tell us what's wrong with this picture.
Well, he's an outlier.
He's an outlier.
Yeah, so the issue with mean is that it takes into account every score, including the extremes, and so that's, he is skewing the data a little bit higher than it actually should be,
Okay,
so it's misleading.
it is misleading. Jenna, do you have a mantra for us, by any chance, or something like a mantra?
Oh, the mean follows the tail.
The mean follows the tail. Let's all say that together. The mean follows the tail. Okay, so the idea would be we frequently have this normal distribution, but every once in a while we get non-normal distributions. And Jen is giving us a really nice example of one that's skewed. And if you look at the small number of people who graduated from the University of North Carolina in the geosciences in 1984, that's a pretty small group. $600,000 a year, well, that's because Michael Jordan is one of them. Okay? And he alone is now creating this skew that brings the mean way out here. Remember that the mean is the one measure of simple tendency that's sensitive to all of the elements in the list, unlike the mode and the median. So you get this positively skewed distribution. A positively skewed distribution will always go mode, mean, and mean, because the mean chases the tail and follows the tail. Okay? So Jen is correct. We always have distributions like this when we're looking at salaries or frequently. Salary is something that's typically positively skewed. It's not normal. It's not the absolute. It has this positive skew. In the video, I mentioned a different kind of positive skew. When we think of another psychological variable that frequently is characterized by a positively skewed distribution. Yeah, go ahead. Reaction time. Right? So most of the time, we're responding pretty quickly, and then every once in a while we zone out and we think about what's coming up on the test, and we're not paying attention to what's going on the screen, and we have a normal reaction. All right. This is something, this is set the stage. In a few sessions, when we begin working on other stats, we're going to learn something called the chi-square statistic. Show of hands, who's used the chi-square in some other science class? Okay. Many other sciences use them. Science of psychology uses the chi-square. The chi-square distribution itself is positively skewed, just like this one. So is something called an Anova, an analysis of variance. The distribution of all possible Anovas will be positively skewed, just like this one. All right. Now we have the negative skew. Negative because the long tail is going off to the left-hand side, which would be the negative side of the x-axis. Here are negatively skewed. Here's our rule again. So Jenna gave it to us a moment ago. Remember that our mantra is the mean chases the tail. So there goes the tail out to the left, and there goes the mean following it. The mean follows the tail. The mode is obviously the largest value, and the median divides those two. So on a test, it might be that you get a question where we'll ask you to draw one of these distributions and put the three measures of simple tendency into their appropriate sequence on the x-axis or the abscissa. So it's really a no-brainer in a Gaussian distribution because the mode, the median, and the mean are right on top of each other. But these three measures of simple tendency begin to spread out one from the next as soon as we start introducing some skews. So now we have a negatively skewed distribution. Can we recall a couple of variables that might be formed like this? Go ahead, Natalie.
Test scores.
Test scores. What can you tell us about the test scores? Exam scores, right? Not something like it. Yeah.
Right.
No, that's fine. Test scores is fine as long as we understand it to mean something like an exam in a course like this, or any dentistry course would probably have, generally speaking, this kind of a distribution. So we get relatively few people who are getting perfect scores, but a good number of folks are scoring in the B and C range, and then fewer and fewer folks are getting close to 0 points. Usually people do a lot better than 0. Even if they wind up failing, they're going to get up at least, that high or something. Okay, that would be one type of variable. So grades on exams, or grades for the course, right, tend to be distributed somewhat like that. Another example. Anybody want to remind us? Go ahead, Giselle. You're just kidding?
Yeah.
Okay, all right. Yeah, she's always kidding. Somebody in the back row, 2 hands went up. Go ahead, Jen.
Gestational periods for
Gestational
humans.
Okay, right. And I used 9 months in the video. I think it's actually a little bit longer. I think the standard is 9 months and 1 week. Yeah, something like that. But then you might go a little bit longer than that. If you don't want to be pregnant for this 10th month, whether you induce pregnancy or not. So that number comes down very quickly after about 9.5 years or so. 9.5 years. Okay. Questions about any of that before we go on to talk about Z-scores? Before we use Z-scores, I'll open up my PowerPoint just like this, and we'll put it into the view that says slide sorter. So So we have all of these different slides. We did a sample of them as we were going through the student questions, and anything that catches your eye here before we get on to Z-scores. That's fine. Thank you for joining us. One thing I will point out here is just that a number that I'd like you to memorize for upcoming tests or read examples is the IQ distribution. It turns out to be an important distribution in psychology, but it's also very handy that it happens to have a mean of 100 and a standard deviation of 15 IQ points. So that's something that I'd like you to memorize because there will be some test questions or homework questions likely on that particular topic. All right, so then let's go over to Z-scores. And we'll ask first just a general motivating question. Can somebody help us out with why Z-scores might be important? What are you motivated to learn about Z-scores? What do they do for us? Okay, Ken,
It's just like a convenient way to like quickly judge how a score differs from the mean. So.
Okay. Okay, that's certainly a very nice advantage of these. We can get some relative information from the Z-score right away. If it's positive, we know that we're above the mean. If it's a negative Z-score, we're below the mean. A zero Z-score means we're exactly at the mean. So that works. And in most cases, we use Z-scores when we have pretty much Gaussian distributed or normally distributed work. So the Z-score gives us relative information. Some other, do you want to add anything to that?
It's a dimensionless measure, so that means that you can compare across different dimensions.
Wow, that's really powerful. Here, is that what you were going to add? Okay, it's dimensions. Jenny, could I impose on you to say a little bit more about dimensions? Because that might be a little bit abstract. That's actually perfect. But if we can unpack that a little bit.
Well, so maybe you want to compare like height and weight, but they're measured in different ways, but you still want to compare them. So this is a way to do that. I don't know.
That's exactly right. So for the rest of the class, if we were to measure height, what unit might we use to measure height? Maybe. What might we use? Inches. Maybe inches or maybe centimeters. People okay with that? If we were to measure weight, what unit might we use?
Pounds.
Maybe pounds, right? Maybe grams. Okay, something like that. You wouldn't use inches to measure weight. So how can we really compare 5 inches to 5 pounds? Right? It's an apples and oranges. You really can't because they're in different units or in different so-called dimensions. Right? But what's cool about the Z-score, as Jenna and Kip are telling us, is it's dimensionless. We get some idea about the relative position of a person in a weight distribution and also where they are in their height distribution. Right? And we simply express the Z-score in terms of the number of standard deviations. So if you're 1 standard deviation above your own mean or above the population mean in height, maybe you're 1 standard deviation above the mean in terms of your weight. So now we can compare apples and oranges by the number of standard deviations or Z-scores. Who's following that? That work for us? Anybody confused by that? Thank you for being confused. All right, we're getting everybody else to say so. All right, so let's see if we can go to the board and draw something here.
Is that what like a BMI chart is? Like a bunch of Z-scores?
A BMI, body mass index, is what you're referring to. A body mass index is in part normalized, but it's actually not a Z-score per se, although you could express body mass index in Z-scores. They're not the same thing, they're distinct concepts. So we can have a couple of Gaussian curves here. We'll stay with the example that I think Jenna was starting for us. We have height in the one case, it's height, and we have weight in the other case down here. And it might be that we can measure height in something like centimeters, if you'll allow me to do that, and something like grams, if I can stay in the metric system. Scientists like to use the metric system down here. So this is one case. Let me pause now and see if Rachel's still there. Is that what it was? Yeah. But Rachel, 5 centimeters is really not, let's just say we're centered at 5. Boy, if you have a height of 5 centimeters, it's not. Okay, why don't we say something like 150 centimeters? And why don't we say that we have however many grams correspond to 150 pounds? Okay, I can even change this to pounds. Pound would still be a measure of weight. So we have centimeters and we have pounds. measurement of height. This might be 150. This might be 150. But 150 centimeters is not the same thing as 150 pounds. Those are different units. Okay? But if you're here and you're here, we can say that you have a 0 z-score here. You have a 0 z-score here because you're at the center of both of those distributions. So even though we don't have a direct way of comparing centimeters to pounds, we can say that your relative position, as Kit was alluding to, is dead center in this distribution, and this hypothetical, you're dead center in that distribution. But you could be dead center here, and you could be 1 standard deviation above over here. If you were 1 standard deviation down here, what would your z-score be? Not a trick question. If you're one standard deviation above, what would your z-score be? 1, okay? A z-score is nothing more than a standard deviation. That's all that is. So if somebody is 1 z-score above here and they're at 0 here, we know something about their relative positions. Right? We know that they're in the 50th percentile here, and they're maybe something like the 84th percentile up this way. Does that help?
Yes.
Okay? And what's cool about that is we just compared weight to height, even though you and I know intuitively that weight is actually expressed in pounds and height is actually expressed in centimeters. Okay? But so this is the apple, that's the orange, and yet we were able to compare them by getting to a dimensionless unit, like something like standard deviation, which we call z-score. Pretty cool. You can do that. It's very liberating. You can compare any kind of variable to any other kind of variable. As long as you go Gaussian distributed, we can compare them. Okay, we're at 220. Thank you for a good conversation. Please keep your eye out for tonight's video. It's already there and ready to go. You have to cut it and paste it with the URL there. And we'll be talking a little bit more about hypothesis testing using these z-scores. Look forward to seeing you tomorrow.
What's our next lecture?
Sorry, my grandmother emailed me. So.
I don't want to go to the library.
Are you gonna go to Vegas?
Yeah. Thank you.
Okay, see you.
Bye.
I did.
That's why I hate